So thank you everyone for getting up early this morning to look at this presentation on Accedian Skylight. So what is Accedian Skylight then? How many of you here know about Accedian from before? One hand, maybe two. Yeah, that figures. So Accedian is a company based in Montreal, Canada, and we're focusing on network and service performance assurance. And we partnered up with Cisco last year. So we are a Solutions Plus partner since the fall. And timing here is pretty good because now in May we are launching our first integration with NSO. So I'm going to talk a little bit about that. So Skylight then, that is the name we call our full suite of solution within Accedian. So the Skylight solution is built out of 3 tiers basically. At the bottom tier we have the sensor layer, so this is where the action happens, where we do testing, injecting packets, monitoring, listening to packets, and creating metrics basically. Then on top we have our orchestration layer. So the orchestration here, you can think of it like an element manager for tests and for sensors. So the orchestration layer consists of a number of components that has APIs for control of the sensors and that sort of thing. On top of that then sits the Skylight analytics layer, and this is where we ingest all the data. We mingle the data, we can take third-party data sources, we can correlate, we can stitch metrics together, do alerting, and of course also feed the data into third-party solutions such as Cisco CNC. So I'm going to focus a little bit more on the sensor layer first, because that's where I mainly work myself. So on the sensor layer, we provide sensors in 3 flavors. So CNFs, VNFs, and PNFs. Starting on the PNF, the physical network function, we have traditionally small boxes for doing probing, but the most interesting one is probably our SFP compute. So this is a pluggable optic that we built in an FPGA that can do testing and monitoring by just plugging this one into a router or a switch that has an SFP cage. So that's an interesting form of doing performance monitoring. VNF, that's a traditional virtual machine, VMware or KVM, that you deploy and you can then do testing of the network service from where that is deployed. And our last addition to the family is our CNF, so our containerized test functions. So this is also what I'm going to focus a little bit deeper on in this presentation because that's my main area of work. So regardless of which form of instrumentation you use when you monitor and test your network, we typically divide the types of tests into 3 different categories. So the first one being what we call the bookmark tests. This is where you have a test function at both ends of the service or of the path. So either you deploy a CNF agent at both ends and do a test between them, or you have a PNF and a CNF, but at least you need a component at both ends. The second category we call reflected tests. So in this case, you leverage some kind of monitoring standard. I'm pointing out a few there. So TWAMP or RFC 5357 is probably the most common one that we see out there. This one leverages a reflector at the far end, basically a mirror. So we send test packets towards that, get them back, and then do computations on the quality of the path. So Cisco, Juniper, Huawei, all of them have reflectors, responders for these types of tests. So then you only need to deploy a sensor or an agent at one end and leverage the reflection at the far end. The last category we refer to as service tests. So in this case, there's also typically just an agent at one end or a test function at one end. And at the far end, you actually call the real service, if it's a HTTP service or an FTP service, a DNS server that you ask queries and then report on the quality and the responses of those. The small boxes with letters in there on this slide denotes in which form Accedian has these types of tests. So C means CNF, V for VNF, and P for PNF. So as you can see, not all of the tests are available in all of the sensor shapes, but we at least can cover the full range with the whole Skylight portfolio. So looking deeply on the containers, which is what I'm going to demo as well today after this presentation. So our CNF sensors, which is our newest sensor type, can be deployed on virtually any type of environment that supports containers. So normal Dockers, we can run on a cloud, public cloud environments, on Kubernetes. We can even run on embedded devices that has Docker capabilities, such as Cisco iOS XR and XE is an example, where there is a third-party application space for containers, so you can run our test agents there if you want. Also, very, very small embedded devices like Raspberry Pis can run containers these days. So there is a wealth of potential locations where you could deploy a CNF agent. The agent itself is reasonably small. Footprint is typically just a fraction of a CPU core to do monitoring. Also, very little disk space and RAM space used to deploy and run these agents. And one important thing to note is that since they are small, they're also single purpose. So you deploy the agent flavor that you want for the type of test that you want to run. So if you want to do a 24/7 type SLA monitoring, then you would deploy the agent that we call Actuate, which has that capability. If you want to do a throughput test, you would deploy the throughput test agent. And since we're adopting to microservice architecture, we do deploy destroy. So you just deploy the agent when you need it, and then you sort of destroy it and shut it down. A couple of more agents mentioned here. I'm not going to go into detail on all of them, but these are the ones we have today. So trace routing, transfer, talking to an HTTP FTP service, downloading data, domain testing, which is DNS server availability and performance. And there's also an SDK of the agent framework that we have developed. So our customers, eventually, we're going to launch this sort of the summertime, can take their own test scripts or test functions and wrap them into an Accedian Skylight test sensor, and then it will automatically plug into our framework and can be controlled, stopped, and get the data feeds through the Skylight platform. So, automation with Skylight. The sensor agents, once they are deployed, they do a phone home type mechanism to register themselves. So in the orchestration layer, which is seen in the middle here, the agent wakes up, phones home, and is then registered as long as it has authentication to talk to the management system. So to launch the agent, basically all you need to provide is a name and an identifier and where to phone home to. So in this case, we call it the management proxy. This is where the agent goes and registers once it wakes up. And no configuration at all is stored within the agent. It's a stateless function. So that helps when you do automation, because you can just deploy it and it will then register and get its configuration from the orchestration layer. Talking about the orchestration layer, so this is where we have APIs and the control of the test functions. An example here showing a JSON of how to set up a throughput test using the API. We traditionally expose RESTful APIs, but we have, together with Cisco, developed also now a RESTconf API so that we could more easily interact with NSOs. I'm going to show that a little bit later, but this example shows just the JSON to do a throughput test. So basically, typically very few parameters you need to specify. We have a name of the test, a couple of IDs that you can auto-generate or let the system generate for you. Then, of course, the test configuration, where to test to, which port, how long to test, etc. So each test agent has different sets of capabilities and also, of course, different sets of configuration parameters. For the throughput test, of course, there is also a start and stop. So that's also an API call that you send in when you want to do the test. So then once the test has been executed, or if you have tests that are continuous, running 24/7 for SLA type monitoring and thresholding and that sort of thing, the data gets into the Skylight Analytics platform. And it's all microservice based, and it's all deployable as needed, right? So if you're only going to use data ingestion and alerting, you only deploy those containers basically of the analytics layer. If you also want to use the more advanced features of analytics, like our correlation engine and ML AI type learning of data trends, etc., then you also add those to the mix. So this is also the layer where we can export the data feeds into, for example, Cisco CNC. So we have done integrations now with Service Health, where we can push alerts from the analytics layer into CNC, and also post the data on a Kafka bus so that it can be accessible to the Cisco systems. Right, so just an example of a couple of screens of the analytics. We of course have our own UI for doing analytics. So depending on how you're deploying the solution, you may use this, or you may instead ingest all the data into CNC and do view and look at the data in that system instead. But there are a couple of important things that we add in this layer. So one is that we can both, of course, ingest the Accedian data, but also take third-party data sources like Cisco telemetry, or we could take SNMP traps from other systems. We could take basically any type of time series data we could ingest into our pipeline. And then we can correlate that with the Accedian monitoring data and also stitch data together to form a composite metric. So let's say you have a path that is consisting of several hops, and you may do monitoring of these hops individually by using different tools or different things. So we can then take, for example, the delay value from the access path and the one from the core or forwarding path together with another access path, for example, and add those together using the RFC 6049, I think it's called, for composite metrics. So we can do a lot of intelligent stuff with the data before we then export it to CNC, for example. All right. So what does the integration look like that we have done so far? I mentioned it's pretty new. So we're launching now in May our Young models and the REST-conf interface for the Skylight solution to work with NSO. So NSO can now then talk to our orchestration services, define a new agent. It can set up tests on that agent. And once the test is running, the data path from analytics can go back into Cisco CNC. I mentioned Service Health for alerting. And so this whole circle is what we have been developing over the past 6 months since we started the Cisco partnership last year. So on NSO specifically, there are a couple of Young models that we've developed for this purpose, both for modeling the test agent itself, but also to monitor the tests. So we started with 2 tests, the TWAMP RFC 5357. So this is a continuous type of test that do 24/7 monitoring. You send X packets per second, and then you will get delayed jitter packet loss type data. And the other agent is the throughput one that can do TCP and also UDP type throughput tests on a path. So both those are now integrated with NSO. And NSO can also, this is an important thing, NSO can also add metadata both to the test and the sessions as well as to the agents. And this metadata is important because that's what you use to correlate things together. You can have metadata tags for geo locationing. You can have metadata tags that tell you which region it is, which type of device you're testing, and so on. And all that type of data adds up and allows us in our analytics layer to do much more fancy correlation of data, doing reports on, for example, that right now there is a lot of packet loss on devices that are running this release of Cisco iOS XR, for example. So if you add all that type of metadata in, we can do a lot more with the data once it's in our analytics layer. Alerting is there, of course, as well. I'm just going to talk more about that, but I have a short demo prepared of the integration. So in this demo, you'll recognize the picture almost. I've set up an NSO instance. I have the Accedian analytics and orchestration deployed, of course. This usually sits in Google Cloud or on a private cloud at the customer prem, but in my demo, it just runs on Google. And then I have two agents. One I already deployed on AWS. The other one, I'm going to show you how to deploy that on standard x86 compute. And we also have an SAP compute deployed, sits at the Accedian headquarters office here in Stockholm. So I'm going to do some testing towards that as well. So first step, we'll go into NSO and look at the the NED definition that we have added into the system. So if we do show packages, we can see we have the Skylight NED loaded in the system. So I can then, I've already then pre-configured the connection between NSO and the Accedian Skylight. So this means I can go into the devices, and there will be one there called Accedian 1. And I can do a show full of that. You will see the type of parameters that you require to add to sort of get the connection going between NSO and Skylight. You need to point it to the URL where the Skylight sits, ports, etc., and a couple of certificates for the communication that will be over RESTconf. So once that's done, we can do a sync from. So NSO then goes and grabs the configuration from the Skylight solution and brings it into NSO. Once that's done, let's use NSO to define a new test agent. So I've done this here in an XML file where I basically generate a UUID, I give it a name, I put which IP address this agent should dial home to when it's registering, a port and some other configurations and a metadata tag there. So once that's done, right, you can import this one. You can do a top load of this config. So we'll do that and then do a commit with a dry run so we can see what NSO will send to the Skylight system. So in this dry run, you will see it's going to do a post to the node at the Accedian Skylight system to add a new agent with the parameters that I defined in the XML. So we'll do the commit, and this agent is now then added to the Skylight system. So here I'm just looking into our own UI to check things out. So I can see that the agent is now there created in the system. But normally you don't need to go into the Accedian UIs to do anything in terms of configuration. But they are there if you want to do some checking out. Next step after defining the actual config for the agent is to start it up, of course. So we'll do that. So to start it up, I've created on a small server. This is an Intel NUC that I run a Linux OS on. I've created a Docker Compose file that contains the definitions for this agent. Basically, again, I'm going to add a config for where it should dial home and a name for it and so on. Then I can basically just bring it up, and it will go to Google Cloud repository and fetch the image layers for this test agent. They're all publicly available on the internet, and then starts up, and you can check that it's running with a Docker PS. All right. So agent provisioned or configured through NSO, agent started up. So it's now ready, and you can start adding tests to this agent. So what we're going to do is we're going to add 2 tests. One test towards a reflector that I have already set up in AWS, and one test towards the SAP Compute Smart SAP that I also have already pre-configured to be a reflector. So let's take a look at how we do that with NSO. So in NSO, we would then have another definition file. So here I'm defining 2 blocks. First one is the test towards the Smart SAP. I name that test Accedian SE. All tests have their own unique UUID, of course. You can specify it in the XML here, or you can let the system auto-generate it for you. You need to specify a rate, how many packets per second, what IP address to target, so this is the Smart SAP IP. And similarly for the second definition here, and unique name, sender rate, and what IP address to hit. And the last one is also important, 30 seconds. So this is how often you report data from this test. So this is configurable. Then just load it as usual in NSO. And again, we're going to do a dry run commit to see what NSO will send to the Skylight system. So this again is going to be post queries to post new configuration. We can then do a commit, and these sessions are now provisioned on the agent. So this provisioning process takes less than a second to do, so it's really quick to get the agents up and running. So we can look in the agent itself. There are a couple of debug commands that you can use. So if you do docker exec on the container agent that's running, we have a command called agent status that you can run. So on this one, I'm going to check that the sessions are provisioned on this one. And of course they are very nicely there. So when the sessions are added, they then of course also automatically will populate in our analytics UI for visualization. So if I search for NSO, I'll get these 2 pop up there, and I can go into and see that we have started to get data coming in from these sessions. And since these were TWAMP, 24/7 type SLA monitoring, the metric set is what you see on the left-hand side there. It's about 50 or so metrics for each direction on delay, jitter, packet loss, percentiles, report a synthetic MOS score, etc., etc. So a number of parameters that you will get there. Just checking also the other test session. Yeah, it's also running. This is the one towards the AWS reflector. So a little bit higher delay values on this one, around 4 milliseconds, whereas the one towards the Accedian office was around 2 milli. So that's showing there. Okay, so let's then use NSO for what it was built for, and that is sort of configuration management, right? And configuration change management. So what I'm going to do is I'm going to change the configuration for one of the test sessions. So instead of reporting every 30 seconds, it's going to report every second instead. So I basically have the same type of config, but with the report interval set to 1 instead of 30. And we can then just top load this file. And let's also have a look at the dry run commit to see what we're going to post from NSO. So in this case, since there is a change of an object, it's going to be a patch. So that's what we see up here. so NSO is going to send a RESTconf patch towards the Accedian system and get the session changed from 30 seconds to 1 second reporting. So we do the commit, and again, this is very quick. The commit is done within a second. The agent is updated with a new configuration and starts then reporting the data at a different reporting rate than previously. So we can check here up again in our analytics platform. If we do a refresh of the data, it has now started to feed the data in a much more granular fashion. So you can zoom in and you can look at the various metrics there. You can of course also create dashboards and all. I'm not going to cover that, but it's a pretty powerful tool. But the most powerful thing here is that you can, with the integration with NSO, we can now then automate these types of changes of configuration in a much nicer way. So you could think of situations where you, for example, based upon a certain type of alert, you want to have higher granularity of your monitoring. So that's a pretty easy automation to build once you have this working with NSO. Triggering on the alert, asking NSO to change config from one type of template to another one, a low res to a high res, for example. All right, so that summarizes my section here today. Thank you very much, everyone. Any questions?
Thank you, Henrik.
Yeah.
Do we have any questions? Oh, several.
Right, good.
I have multiple questions actually, but I will take only two. The first one is, I understood that for the test agent, is it dedicated to a specific testing type, or I can use different sessions on the same test agent?
Yeah, it depends a little bit on the agent. The one I used here, it's called the Actuate agent. That one can do RFC 5357 T1. It can do UDP echo, ICMP echo, those three types of tests.
Okay. The second question is, if I'm testing multiple services, shall I create new interface every time, or this will be created automatically on the test agent that I have identified?
So the test agent, so right now the test agent can only attach to one VRF. In our next release, we're supporting multi-VRF, so then you can have one VRF per session, basically. And each agent, depending on where you deploy it, scales up to 100 or so tests if you use it continuously.
Okay.
So you could then have tests going out to different VRFs. Yeah.
Okay, thank you so much. I will leave for those.
And how does your solution deal with a meshed environment where you have customers with thousands of endpoints and you want to test the whole service?
Yeah, that's a very good question. How much time do we have?
Well, enough.
Enough, all right. Yes. So, yes, when you mesh, you end up with a lot of mesh combinations, right? It's the N exclamation and divided by the, you know it. So one method of addressing the mesh is to do a partial mesh, right? Because if you do a full mesh, you're going to end up with so much data that you're probably not going to want to bring that data back to your analytics tools. So we say that a mesh is typically okay if it's less than 100 nodes. If it goes above that, for a full mesh, I think you're going to run out of resources. If you're doing continuous testing, since we support automation, right? You could have templates that test this region, a mesh for 2 hours, then shut down the containers and do another test at a different location. That's also something you could do, but the whole idea of doing things like T1, continuous monitoring, is that you want to be alerted when something is wrong. You just don't want to do a test during a 2-hour period and then be blind for 22 hours. But okay, did that answer your question? Or?
Definitely. But for long-term monitoring, you're perfectly right. But also for like service commissioning, we have a lot of requests from our customers that they want to make sure if they make changes to an existing service and add additional endpoints, they want to be able to have like a a certificate that everything is working as expected and the customer's intent is being deployed on the network. So it's not long-term persistent, but to be able to test the whole customer service with the additional modifications one time.
Yeah, exactly. And that's where I think the throughput agent that we have is useful. You can also throttle that one. You can say, don't go over 100 megs or 5 gigs or whatever you throttle it to. So you can then get as a birth certificate basically out of that. And we're storing those, of course, in our analytics layer, and we can do comparisons between test runs and so on quite nicely.
Thank you.
Right, do we have time for one more question?
Absolutely.
Okay, good. I thought there was one, but maybe, yeah, okay.
Hi, can you bring more details regarding licensing model?
Yeah, so it's quite easy. Agents are free of charge. You download them directly off the internet, but you can't use them actually unless you have the Skylight solution behind it. So the licensing takes place in our analytics layer, but we use a trust and honor model. So that means that all our customers that have Skylight have access to agents, and they can use as many agent tests as they want. But we're doing monthly calculations on how many test paths that you were using during that month, or we could do yearly licensing as well. So it's basically as a cost per path that you do a testing on.
Okay, thank you. No more questions?
Yeah.
All good.
Okay, Jens,
Thank
thank you.